A, then B is the square root of A. Okay? The radical symbol, the square root, represents a non-negative square root, because tomorrow we're going to look at when you take a negative square root. Can't do that. Radical, an expression of the form square root of s. Just when you have anything with a square root in it, it's called a radical. The number underneath it is called a radicand. Rationalizing the denominator, the process of eliminating a radical expression in the denominator. We're going to do that today. Conjugates, we're going to work with conjugates today to get rid of square roots in the denominator. So that's just some terms of what we're doing. But first, let's simplify. Now, ladies and gentlemen, when it says simplify, it does not mean go to the calculator and take the square root. No decimals in your answer. No decimals. So, what you need to use is you need to use the perfect square list. I always kind of like make a list of the perfect squares. What's the smallest perfect square?
4.
Because the square root is an integer. So that's 2 times 2. What's 3 times 3? 4 times 4. 25, 36, 49, 64, and it keeps going. You're going to use this list to help you simplify. Okay? So, when you have to simplify a square root, you have to think of factors of the number that's underneath there. The biggest factor that's a perfect square. Biggest factor from this list. What's the biggest factor of 75? 25. So the square root of 75 is actually equal to the square root of 25 times the square root of 3. I'm going to stop right there and make sure you do it. So then I take the square root of whatever I can. I can't take the square root of 3. It'll give me a decimal. It can't be part of my answer. So I just leave it in that form, and that's my answer. Remember this? Okay. Let's do this quickly then. Square root of 27. What's the biggest factor? 9. Alrighty. So I can write that as the square root of 9 times the square root of 3. Now I can take the square root of 9, which is 3, times the square root of 3. Can't go any further? Can 3 be divided by anything on that list? No. Okay? All right. Biggest factor of 300 that's on that list.
100.
So I write it as the square root of 100 times the square root of 3. I can take the square root of that, and that's my answer. Can't go any further. Okay, sometimes you'll get to a number that maybe it doesn't quite come to you right away. I just take that number and I start dividing it by these. Okay, and see which one works. And actually, yeah, it's 49. Square root of 49 times the square root of 2, because 49 times 2 is 98. 7 times the square root of 2. Okay? All right, now, sometimes, you don't have to write this if you don't want to, but sometimes you have to put them together. To get a perfect square factor. Sometimes you have to put them together. Now what I mean by that is, we took here and split them up. Can't we put them together under 1? If I multiply 7 and 35, I get the square root of 245. And you're saying, yeah, so? Yeah, but 245 has a factor on this list. Does anybody know which one it is? 81's too big. I would keep going. I would then go divided by 64, see if that works. Then I would go divided by 49. Oh, that's it. I'm sorry, what? And then it would be 7 times the square root of 5. So sometimes you got to play with it a little bit to see if you can find a factor that's a perfect square. So if I put this one together, I get the square root of 150, which helps me how? What's the factor on this list, you think? 25. All right, 5 times the square root of 6. Can 6 be divided by anything over there? No, then you're done. Okay? All right. Now, sometimes it doesn't help to put them together. I'm going to do this one first over here. This is all multiply, isn't it? Yeah? Can I write multiplication in any order? It's commutative, right? So I'm going to do 3 times 4, because this might help me solve this. Okay. Can I multiply these together? Sure. 12, that's on the outside. It doesn't really affect my factoring at all. Now I'm going to look at these and I'm like, I can't do anything with them like that. If I put them together, can I do anything with them? Is there anything on this list? No. So this is just going to be my answer. This is the most simplified form of that. It is the most simplified form of that. This one I kind of looked at and I'm like, well, 8 times 28, I don't think that'll help me at all. But 8 has a factor on this list, doesn't it? 4. You can put it together too. You can do it either way. Absolutely. All right, and 28 has a factor on this list. What is it? 4. Okay. So instead of multiplying them together, I saw that I could do this. Doesn't matter which way you go. What's the square root of 4? 2. What's the square root of 4? 2. And it's all multiply. It's all multiply. And then I can put these two together under 1. And I get 4 times the square root of 14. I always stop and say, does 14 have anything on that list that I can divide by? Nope. Those are both perfect squares, so this just equals 10 over 13. You cannot divide them, no decimals in the answer. You just leave them like that. All right, so this one too. Aren't they both perfect squares? So what's the answer? 3/8. Okay, so this one. 11 is not a perfect square, so I'm going to write it like this just to get started. Can I take the square root of 11 without a decimal? No, so I'm going to leave that in the top. And what's the square root of 144? All right, I can't go any further than that. Because 11 does not have a factor that's a perfect square. So I'm done. All right, here we go. Same with this one. Square root of 15 over the square root of 4. My goal is always to get rid of the radical in the denominator. Square root of 15 over what? 2. Can 15 be divided by anything on that list? No, so you're done. All right, now we're going to get to the part that's called rationalizing the denominator. We're going to have to work a little harder to get rid of that square root thing in the bottom. You cannot leave an answer with a radical in the bottom of a fraction. So what I do here is, first of all, I split it up. Tracy, do we have to? Okay, I'm splitting it up. Now I can see right now that I can't do anything right now. So I have to get rid of that thing in the denominator. So what I do is I multiply by a fraction like this, which is using the denominator, and it's really just multiplying by the number what? 1. Because isn't this equal to 1? Yes. Square root of 15 over square root of 15 is 1. Right? Okay, here's what it does for me. It's beautiful. So I'm going to multiply across, because that's how you multiply fractions. And I'm just going to write it like this. Square root of 30 is in my numerator. Do you know how I got that? 2 times 15. 2 times 15, and I put it underneath 1. Now, what is the square root of 15 times the square root of 15? 15. Oh, got rid of it. I'm in a good spot. Can square root of 30 be divided by anything on that perfect square list? Can I take it any further? So that's your answer right there. Yeah, multiply by the square root of 8 over the square root of 8. Okay. Now I'm going to write this. I'm going to skip a step, but I know in my head that this can be divided by 4, so I'm going to write it like this in the numerator. And then what would my denominator be? What's the square root of 8 times the square root of 8? 8. So I'm not done yet. What can I do? Yeah, I can take the square root of 4. I can take the square root of 4. Wait, I hear a question. Please don't let me keep going if you're not sure. Oh, but guess what? This fraction on the outside can be reduced. This is just a fraction on the outside. What can I divide them both by? 2. So it's going to be 3 times the square root of 2 over 4. I reduced this outside fraction because I have to. Come on, don't think of it as pain. It's fun. Well, from up here. Because I thought about 8. I know 8 is the same as the square root of 4 times the square root of 2. What's up, Tracy? You with me? Because it doesn't get easier. I want to make sure you get this before we move on. Yeah, Jenny. Like which other ones? Like I can't. There's nothing else I can do with these. What are you thinking? Do you understand why there's nothing else we can do? We went as far as we can with these? No, don't. Are you sure? Okay, let's keep going. Here we go. Is you multiply by the conjugate of this, which is 5 plus the square root of 2. That's why I had you do that on the front. That's why I had you FOIL. So you can see what happens when you do that. Again, it's just like multiplying by 1, but what it's going to do is it's going to help me get rid of that square root in the bottom. If you look at it this way, remember you multiply across, you're multiplying fractions together, correct? Multiplying fractions together. Oh, here we go. This is totally different. This is totally different than what we just were doing. Easiest way to solve is get x by itself. Get x by itself. Okay? So, I am going to just solve this like an equation. My goal is to get x by itself. It's totally different than what we were doing up here. So all I do is I add 15. I get 2x squared equals 80. And now what can I do to solve this problem? Yeah, let's get rid of that squaring. So take the square root, and I get x minus 2 equals plus or minus 3, correct? Okay, not done yet. Now I've got to add 2, but wait, I have to add 2 to positive 3, and I have to add 2 to negative 3. So x equals positive 3 plus 2, and x equals negative 3 plus 2. Because when you take the square root of something, you have a positive and a negative version. And when you introduce that into solving, you have to consider both of those. And so those are your answers right there. Decimals. When it says about, I can use decimals. So I take the square root. And t is equal to approximately plus or minus 3.9 seconds. Well, does negative 3.9 make sense?
No.
No.